Welcome back, pre-algebra. We're in lesson 20 today. We're going to talk a little bit about multiples. We know that we can multiply numbers in our multiplication table. 1 times 2 is 2, 2 times 2 is 4, 3 times 2 is 6, so forth and so on. Those are called our multiples. The products of those numbers are the multiples. So the multiples of 2 would be 2, 4, 6, 8, 10, 12, and we get those multiples by saying 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, 2 times 6. We go down the row of the counting numbers. We never start with 0. We always start with our natural numbers. So 2 times 1, we could almost do a little grid. 2 times 1, 2 times 2, 2 times 3, 2 times 4, 2 times 5, and 2 times 6. Those are the multiples that we have here of 2. We could do the same thing with 3. It's kind of just like a multiplication table where you have just the answers, right? 3 times 1 is 3, and then you have 6, and then you have 9, 12, 15, 18. So these are the multiples of this factor. All right, very easy to understand. You're just multiplying times the next counting number, or as we learned when we learned our multiplication tables, we're just adding this original number to the answer each time, and it's kind of like skip counting. You're just going to the next and the next and the next and the next. So the number 8 is a multiple. This is problem 20.1. The number 8 is a multiple of which numbers? So we're looking for 8. Where does it fall? So we want to start with the smallest number. We know it's a multiple of 1. We're going to skip 1. Everything is a multiple of 1, so that is not the answer. Said we start with 2 and we look. Is 8 a multiple of 2? Well, we've already done it up here. I'm just going to rewrite it. 2, 4, 6, 8. Yes, it's a multiple of 2. All right. Is it a multiple of 3? 3, 6, 9, 12. No. Then once we go past 8, it's not it. So it is not a multiple of 3. Is it a multiple of 4? We have 4, we have 8, we have 12. Yes, it is a multiple of 4. Is it a multiple of 6? 6, 12, 18. No, it is not a multiple of 6. What about 7? 7, 14, 21. Nope. What about 8? It is a multiple. It is 8. So it has to be a multiple of 8. So it is a multiple of 1 because everything is a multiple of 1, and I didn't want to waste our time with that. It is a multiple of 2. It is a multiple of 4. And it is a multiple of 8 because it is 8, right? Finding the multiples also gives you the factors. So I don't know if you can see that, 1 times 8 is 8, and 2 times 4 is 8. So the multiples that give us 8 are also the factors of 8. That is a very interesting idea. So now you don't have to go through the ones that you know are not factors. You can just look at the factors of 8 and pull them into the multiples list. So now let's do 20.2. 20.2 says to find the multiples, if I can spell that right, multiples of 9 that are less than 50. So let's find the multiples of 9 that are less than 50. We'll start with 9. So we have 9 times 1, 9 times 2 is 18. 9 times 3 is 27. 9 times 4 is 36. 9 times 5 is 45. 9 times, what was 9 times 5? 9 times 6, though, is going to be 54. So the multiples of 9 that are less than 50 are these right here. 9, 18, 27, 36, and 45. So sometimes we are in a situation where we need to find common multiples between two numbers for the sake of doing some type of operation. And usually what we want to do is find the least common multiple, right? Because the least common multiple is going to be the first one you come to that they both have in common. That's where least, the first one you get to, is going to be the lowest one. Common means that they are in both groups, and it's talking about multiples. So the least common multiple is what we're looking for. Because if we kept going, there is no greatest common multiple, because you could just keep going and going and going, because there is no end to numbers, right? The least common multiple is what we're looking for, and we call that the LCM. The LCM is the least common multiple. So let's look at the least common multiple of 2 and 3. So we want the LCM of 2 and 3. So we know that the multiples of 2 are 2, 4, 6, 8, 10, and so on. And the multiples of 3 are 3, 6, 9, 12, 15, and so on. So the least common multiple of 2 and 3 is 6. So notice that the least common multiple between two numbers can sometimes just be those two numbers multiplied against each other. How interesting is that? That is a cool relationship when you think about it. So just to find the least common multiple, we are able to multiply them to get that number without having to list all of these out. So let's look at a group of 3 numbers. We're going to find the least common multiple. We're going to find the LCM of these 3 numbers, and let's see how that works. 18, 81, and 500. Whoa. So what we have to do in order to find the least common multiple is to find each factor. Remember how we multiplied 2 times 3 to get 6? Well, each factor of 2, well, the only factor of 2 was 2 and 1, and the only factor of 3 was 3 and 1. They both had a common factor of 1, so we disregarded that, and we just multiplied 2 times 3. And that just, that is pretty cool how that worked out. We can do the same thing to find the least common multiple of these numbers. I mean, just think if you had to try to do the multiplication table for each one of these, that could get pretty cumbersome, and it would take up a whole lot of paper, which I am not up for. There's a faster way, and that is to find the factors of each number to find the LCM. So for 18, we are going to find its factors. So I know that 18 is 2 times 9, and 9 is 3 times 3. So 2 times 3 times 3 are the factors of 18. So I'm going to look at the factors of 81. And that is 3 times 3 times 3 times 3, because I know 81 is 9 times 9, and 3 times 3 is 9. So that would be 3 4 times. And I'm going to look at the factors of 500. I know that's going to be 2 times 250, right? 250 is 2 times 125. 125 is 5 times 25. And 25 is just 5 times 5. Now we can find the least common multiple by using the procedure in step 2. And that is to compute the LCM by using each factor as a factor in the LCM the greatest number of times that it is given. So what we're going to do is we're going to find the greatest number of times that each factor is used per number. So here we have 2, and then we have 3 squared, right? 2 and 3 squared. All right, here we have 3 4 times. Here we have 2 2 times, and we have 5 3 times. So now we just need to look at each base and use the base with the biggest exponent that matches. So I have, let's start at the beginning, I have 2, and whenever you have a number by itself, a factor by itself, it's to the 1 power. All right, so which one is bigger, 2 to the 1 or 2 to the 2? 2 to the 2 is bigger, so we can cancel that one out. Which one is bigger, 3 to the 2nd power or 3 to the 4th power? 3 to the 4th power is bigger, so we can cancel that one out. 5 to the 3rd power is not used anywhere else. So we are going to use these factors in order to find the least common multiple. So all we have to do is multiply 3/4 times 2 squared times 5 cubed. Now we already know what 2 squared times 5 cubed is because it is right here 500. So we can just cross that out and say 500. And we also know what 3 to the 4th is because it's right here, it's 81. So I can cross that out and I could say 81. So now we know that 81 times 500 is the LCM for all 3 of these numbers. So then all you would have to do is pull up your handy dandy calculator and say 81 times 500 is equal to 40,500. And that is how you find the LCM. You're going to find the base with the highest exponent, or you're going to use the base with the highest exponent per base that matches. So anytime you have a different base, you don't compare it to other bases. You compare it to the base is the number that has the exponent, right? It is the whole number that you are multiplying. That's what we call a base. And then the exponent is the power. So you're going to look for matching bases and use the highest power exponent. And you can cross out the other one. All right. So another way that you can think about it. I know this is a little confusing. I like to do it like this. I have 2, and then we had 3 times 3, right? Up here. Actually, I'm not going to rewrite that for you. I am just going to use a method that I like, which is pairing. So what I do is I find pairs of numbers and I write them down. So I'm going to cancel these together. So I'm going to look for factors that are the same and cancel them out. So this one cancels this one, so I have a 2. This one cancels this one, so I have a 3. This one cancels this one, so I have another 3. This one and this one are by themselves. They're done. The 2 is by itself. 5, 5, and 5 is 5 times 5 times 5, which is the same thing we ended up with. But if you can cancel out pairs, or if you had another 3 down here, you can cancel it out, that works well also. But the number does not have to be in each one of these. It just has to be in another set at least one time. If this is too confusing, use the original method that I showed you, where you just use the highest power for each base, and then you multiply them together. All right, so let's move on and let's try a practice problem. Let me clear this. And we're going to find the LCM in 20.3 for 24, 55, and 80. So first we're going to write the prime factorization of 24. 24 is equal to 2 times 12, which happens to be 2 times 6, which happens to be 2 times 3. The prime factorization of 55 is 5 times 11. And the prime factorization of 80 is going to be 2 times 40, which happens to be 2 times 20, which happens to be 2 times 10, which happens to be 2 times 5. So now I have my prime factorization. So what I'm going to do is I'm going to use my exponents, which makes it a little bit easier. Here I have 1, 2, 3 2's, so 2 to the third power times 3. I have 5 times 11, so that's 5 times 11. And both of those are to the 1 power, and the 3 is to the 1 power. And then here I have 1, 2, 3 4's. I wrote that wrong. I have 4 2's, so 2 to the 4th power, and 1 5. 5 to the 1 power. All right, so I only see 2 bases that are the same. I see the 2's and I see the 5's. So the 2 to the 4 is a bigger base than 2 to the 3. I'm sorry, not a bigger base, but a bigger exponent. So I can cross out 2 to the 3. 3 to the 1, there's not another 3 base anywhere, so that one stays. 5 to the 1 is duplicated here, 5 to the 1, so I can get rid of one of those. And 11 to the 1 is used only one time by itself. So now I can multiply 2 to the 4 times 5 times 11 times 3. And that is all of my factors that I have remaining. So I know that 2 to the 4th is going to be 16, because 2 times 2 is 4, and then 2 times 4 is 8, and 2 times 8 is 16, and that's all 4 of my 2's. So I'm just going to rewrite this as 16 times 5 times 11 times 3. And actually what I'm going to do is I'm going to say 5 times 11 is 55. So I'm going to rewrite that as 55. And then those are the numbers I'm going to multiply, because I can't do the rest of this in my head. So 16 times 55 times 3 is equal to 2,640. And that is the LCM for those 3 numbers. The least common multiple is 2,640 for 24, 55, and 80. All right, so that is the way that you would do it. That's the way you would find the least common multiple. We have one more example problem, 20.4. We're going to show 3 numbers expressed as products of prime factors. So the first number is 2 times 2 times 3 times 7 times 7. The The second number is 2 times 2 times 2 times 2 times 5 times 7. And the third number is 2 times 5 times 5 times 5 times 5. And the problem asks us first, what are the numbers? So, and then it asks us, what is the LCM? So we can easily find the numbers. All we need to do is multiply. So I'm going to pull up my calculator because these look like they might be big. And I'm going to say 2 times 2 times 3 times 7 times 7. 588 is the first number. And by the way, if I have to use the calculator, it is okay for you to use the calculator. Just saying. I'm not going to make you do something that I'm not going to do. And when you get to numbers like this, where the product is large, it's okay. Now, if you, for your own sake of making sure you still know your multiplication tables, want to write it out longhand, go for it. But if I'm doing it with a calculator, I don't have a problem with you doing it with a calculator. But I would like for you to try, when we have smaller numbers, to do them in your head. So I have 2 times 2, which is 4, times 2, which is 8, times 2, which is 16. And I know, all right, so that is all 16. And I know that 5 times 7 is 35. So I'm just going to multiply 16 times 35. It's 560. So 560 is the second number. And the third number, let's see. So 2 times 5 is 10, and 5 times 5 is 25, and 25 times 5 is 125. So I know 10 times 125 is going to equal 1,250. So those are the answers to the first question. And the answer to the second question, let me get rid of my little notes right here. The answer to the second question, what is the LCM? Let's evaluate it. So we have 2 squared times 3 times 7 squared. All right, and 3 is to the 1. I have 1, 2, 3, 4s. So 2 to the 4th power times 5 to the 1 times 7 to the 1. Now you don't have to write the 1. I'm just doing that to illustrate the fact that it's only used one time as a factor. You can just write it without the exponent to show that it's just used the one time. It's understood that when you write the factor by itself like this, that it's just being used one time. So don't let that throw you off. And I have 2 to the 1, and then I have 1, 2, 3, 4. Oh, that's not right. Oh, yes it is. Yes it is. Okay, I'm sorry. I was racking my brain here. I put this 5 with the 2 and made 10. So that's perfectly okay. All right, so 2 to the 1 and then 5 to the 4th power. So now we're going to look at the 2's. That's one of the reasons why I do them in numeric order. It's easier to find like bases when they're all in the same order, right? So of the 2's, which one is the biggest? The 4th. So I'm going to cross out this one and cross out this one. There's only one 3, so we leave it. We have a 5 and a 5 to the 4th. 5 to the 4th is bigger, so we cross out that 5. And of the 7's, we have a 7 to the 2 and a 7 to the 1. We cross out the 7 to the 1. So now we know what factors to multiply. 3 times 7 squared times 2 to the 4th times 5 to the 4th. So now I'm going to go in here and I'm going to do the multiplication. 3 times 7 squared is 49, because 7 times 7 is 49. And 2 to the 4th is 16. And I have no idea what 5 to the 4th is. That's 25 times 25. I have no clue what that is. I do know that 25 times 5 is 125, and that leaves another 5. And I know that 3 times 5 is 15, so I'm going to make that 15 and cross out the 3. So now I'm going to multiply these numbers because they're bigger than I can do in my head at this point. So I'm going to say 49 times 16 times 125 times 15 equals, oh my goodness, 1,470,000. So that is the answer. 1,470,000 is the least common multiple of these numbers right here. All right, so that is all we have for lesson 20. You should now know how to find the least common multiple. You should be able to put the least common multiple into an exponent form, and then you should be able to, you should be able to put the factors or the numbers into prime factorization, and then put that factorization into exponent form, and then from there find the least common multiple by determining which base has the highest exponent and using that in your multiplication to find the least common multiple. All right, if you have any questions at all about that, please message me. We can go over it as many times as you need until it clicks. Sometimes it takes people longer to get a concept, and there is absolutely nothing to be ashamed of about that. It just takes some people longer. That doesn't mean anything bad. It just means that's the way it is. Some people get history and understand history and memorize it and know it easily, but yet math comes harder to them. Some people can write so well, the words are just part of who they are, and yet history or math are hard. Some people, math comes easily, but then the other things are hard. We are all different. We are all different on purpose and created to be unique. So do not let the fact that it's a little hard for you make you feel bad. That's okay, because I am quite confident that you are good at something else, and that is what makes you special. So contact me if you have a struggle with this. I am more than happy to help you figure it out however you need to figure it out. And that's all I have for lesson 20, and I will see you in lesson 21.